And this will be a product that electronically deletes surge. This is a video going through an article on the MoviChip website. Link to the article in the video description. Go through exactly what is causing turbo compressor surge and what we can do to fix it. So first off, what is turbo compressor surge? Turbo compressor surge is an aerodynamic phenomenon that happens when the rotation of the compressor wheel is too fast versus the speed of the air passing through the compressor. The points where this happens is what makes up the surge line. So we've got a compressor map here, and we can see that the surge line is along this line here. We've got airflow along the bottom, and we've got boost or pressure ratio up the side. So we can see when the boost gets too much for a certain airflow, we go to the left of the surge line, and this is where our surge is occurring. This is what's causing the turbo surge, that fluttering, that we get from the turbo under higher loads at usually lower RPM. It's because we're in this area of the turbo compressor map. What is happening when we hear that sound are the blades of the compressor wheel no longer compressing the air. The speed of the flow through the compressor is too slow for the compressor wheel to be able to maintain the pressure that we're asking of the turbo system. So that sound that we're hearing is the boost getting released as the pressure relieves itself as it goes back through the compressor in the reverse direction. It's a stall, I think, is the best way to describe it. The blades on the compressor wheel are stalling. They're no longer able to maintain the pressure, so the pressure gets relieved back through the compressor, and that is what makes the sound. Where this happens, or when this happens, will depend on the engine map, but generally speaking, it usually occurs when we're asking for a higher boost pressure at low to mid RPM. The problems with turbo surge is turbo wear. We're putting stress on the bearings because the turbo is alternating between making the boost and then not making the boost, and that's happening rapidly. We're going from boost to no boost, boost to no boost. This is putting stress on the turbo bearings. From one minute they're pushing the air to the next minute they're not. We're creating an axial force on the bearings inside the turbo, and that will cause premature wear. We may even be putting excess stress on the turbo shaft as there's pressure against it, and then we're suddenly releasing it. All in all, it's a bad situation. Can be catastrophic, but I think in most cases it's a gradual wearing out of the turbo over time. Obviously it depends how bad it is. I mean, if it's a catastrophic turbo surge that we're having, like big boost going down to low boost rapidly, then obviously the worse it becomes. So how to fix compressor surge? Fortunately, it is possible to remedy the issue. We can stop the surge from happening. To stop it from happening, we move our turbo where it's operating away from the surge line. We move the spot where we are on the compressor map to the right of the surge line. So coming back up to the compressor map here, surge is happening here. To cue the surge, we want to move the compressor, or the point where we are on the compressor map, to the right. We can either do that by increasing the RPM or increasing airflow through the engine, or we can do that by reducing the boost that we're asking for at that level of airflow. So we can either go in this direction to get to the right of this surge line by reducing the boost, or we can go to the right of the surge line by increasing the airflow through the turbo. We can't magically make the engine move more air at the same boost and the same RPM, but we can gradually reduce the boost at RPM where the surge occurs until the problem stops. So say we're here, the turbo is surging, we just gradually reduce the boost pressure that we're asking for at that RPM until we come to the right side of the surge line. For example, we have a turbo surge at 3,500 to 4,000 RPM at 30 psi of boost. We can start reducing the boost, the maximum boost that we're achieving in this RPM window until the surge stops. How much the boost needs to be reduced will depend on the engine, its volumetric efficiency, and the size of the turbo. So in a nutshell, to eliminate turbo compressor surge, we reduce the boost pressure at the conditions where the surge is occurring. Are there any downsides to doing this, reducing the boost at the RPM where the surge is occurring? None really. I suppose reducing the boost pressure will be reducing the amount of power that the engine can make, but at the same time we're in a surge condition when we're making that level of boost, so we weren't being able to harness that power effectively anyway. We also have the added benefit of there being less stress on the turbo, which is what we're trying to achieve, and we're also having an engine which is easier to drive, more consistent, and we just have a happier engine all round. There is another alternative solution to turbo surge that can potentially allow us to run us the same boost pressure as when the surge was occurring. In that previous example, we reduced the boost pressure to get to the right of the surge line. But if we can increase the airflow through the turbo at the same RPM, we can also maintain our boost pressure. And this is where your anti-surge compressor housing comes in. They allow air to be diverted around the compressor wheel back into the intake. So this keeps the airspeed up. Downsides with that is that we don't really have much control over it. It's happening all of the time, even when we don't need it. So the air is flowing around the compressor even when we're not in a zone where the turbo will be surging anyway. Another downside to the anti-surge, spelling mistake here, another downside to the anti-surge compressor housing is if your turbo doesn't have one. So if you're having surge and you want an anti-surge compressor housing, you're either going to have to machine out your existing compressor housing, if that's even possible, or probably more likely just buy a complete new compressor housing which has the anti-surge built into it. And it depends on the popularity of the turbos. Sometimes there are aftermarket solutions for set turbo sizes which have anti-surge housings in them. And obviously, as you can imagine, whether you're machining the stock compressor housing to put an anti-surge into it, or you're buying an aftermarket complete compressor housing that's got anti-surge in it, that's not going to be it's not going to be easy to do it. I mean, you're going to have to disassemble the turbo. Either way, either you're going to be disassembling it to machine it, or you're going to be disassembling it to fit that new compressor housing. So not easy, and not a cheap solution. And just to wrap up, really the purpose of this article, why we started on it, is MoviChip is researching a product that will delete compressor surge, but it will do it electronically. So it will only be deleting the surge where surge can occur, so we get the full benefit of the turbo that we're using. We're not going to be wasting any air out of the compressor housing with it like you would with an anti-surge housing. And it will also allow us to maintain our current boost pressure without having the surge. If you want to receive updates on this product, it's in development at the moment. I expect it's probably going to be available in a month or two from the time of this video is uploaded. So if you want to receive updates on that, go to MoviChip, subscribe to the newsletter there, subscribe to the MoviChip YouTube channel as well. We'll be updating demonstration videos on it. Thanks for watching. Look after yourselves. I'll see you again in the next video.